Iceland lies on top of the North Atlantic oceanic ridge, where the Earth's surface plates are parting at an average rate of 2 centimeters a year. That is, 20 kilometers over the space of 1 million years. Molten rock, magma, wells up beneath the North Atlantic oceanic ridge. An additional volume rises towards a hotspot in central Iceland. This is the fiery heart of the island. Plate movement and ascending magma cause volcanic activity at the average rate of 1 eruption every 4 years. A great deal of magma solidifies within the crust. An active volcanic zone covers 1/4 of Iceland. There the crust splits open within 30 individual fissure swarms. Each swarm contains many volcanic fissures, open cracks and faults, and most also hold a large, centrally placed volcano, a volcanic center like Hekla and Grímsvötn. The individual fissure swarms are termed volcanic systems. Low temperature areas occur outside the active volcanic zone, producing hot water, not steam. Southwestern Iceland contains 4 volcanic systems. Volcanic eruptions have often occurred there since the time of the settlement of Iceland, and especially in the 12th and 13th centuries. The Hengil Volcanic Center and the Thingvellir World Heritage Site are both situated within one of these systems. The last eruption within this particular system occurred 2,000 years ago. Volcanic tuff formations and young lava flow are both common within the Hengil volcanic system. Conspicuous geothermal areas with steam vents and mud pots, as well as volcanic fissures, which are 2,000 to 10,000 years old, line the system. The geothermal areas in the Hengil volcanic system are high temperature areas created by volcanic activity and magma intrusions into the crust. The same applies to other high temperature areas in Iceland. Bedrock surveys have revealed what lies underneath the Hengil central volcano and its vicinity. The bedrock is mainly composed of lava flows and glassy tuff, which is an eruptive rock dating from the Ice Age. The bedrock is still very warm at a depth of a few kilometers. Lower down, it grades into magma, which is probably contained within magma chambers. From time to time, magma may flow up into these chambers from further down below, or squeeze into the crust around them. Temperature surveys show that the bedrock temperature increases with depth. The bedrock is hottest close to or within old and recent magma intrusions into the crust. At a depth of 1 to 2 kilometers, the temperature measures 240 to 320 degrees Celsius. But how do geothermal areas with hot springs, colorful chemical deposits, various clays, and warm effluent water come about? Most geothermal areas appear where bedrock cracks and fissures allow hot water or steam to ascend to the Earth's surface. The water and the steam are acidic and transform rocks into clays. Solidifying magma warms the bedrock beneath the Hengil high-temperature areas. Precipitation, seeping into the bedrock, flows towards the hot rock masses either in the form of cold groundwater or as already heated water coming up from greater depths. The water rises and sinks in leaky rocks close to the heat source through the process of convection and draws heat. Some of the geothermal fluids surface through channels and fissures, forming a geothermal area. Geothermal energy has to be utilized in a sustainable way. We have to care for our resources and conduct energy production with great responsibility. To do this, you must construct a physical, mathematical model of the harnessed area, compose a utilization forecast founded on surveys and monitoring, place the boreholes and wells correctly, and not over-exploit the geothermal reservoir. But geothermal energy is not just restricted to Iceland. Across the world, wherever tectonic plates meet, Energy can be harnessed by using the same methods that Reykjavik Energy has become an expert in, as a means of generating green energy. Reykjavik Energy's experience and expertise in the field of geothermal energy can make it an example to nations all around the world. High-temperature fields, therefore, represent an unlimited, self-sustaining resource for a clean, living Earth.